Hello there you beautiful people and welcome back. Now in the last video we put our files into a tarball and now we want to learn about how to compress that tarball to save space on our hard drive. Now compression happens using compression algorithms and there are two main compression algorithms in use in the Linux world. And the first is the gzip algorithm and the second is bzip2. Okay, and the main difference between them is usually gzip is faster but has less compression power, and bzip2 on the other hand can generally compress files to a smaller size than gzip but does require more computational time. So both of these compression algorithms are really easy to use, so let's just start by talking about gzip. Okay, so to compress a tarball using gzip, all you need to do is type gzip and then the archive name. So here we are, our archive.tar, and press enter. And we'll see that that file has been compressed in place using the gzip algorithm, and we can see that it has, if we use the ls command here, we can see that the .gz file extension has automatically been added, and we can use the file command to confirm that yep, this is indeed gzip compressed data, and it was our archive.tar. Okay, and it tells you when it was last modified as well. Okay, so that's really cool. We can see quite a lot of information about that. Now let's take a look at the file size. So if I do the ls command with the lh option, actually no, let's just the l option. We'll see that file 1, file 2 and file 3 are 10,000 bytes in size, but our archive, the compressed archive, is only 23,000 bytes. So it's about 7,000 bytes or 7 kilobytes less than what the files would have been originally. So we actually have managed to do a compression of about 23%. So that's not bad. Now this will vary from file type to file type and what you're actually compressing, but in this case we got a compression of 23% with gzip. So notice how compression is a two-stage thing. First we make a tarball, and then we compress that tarball with a compression algorithm, okay, which in this case was gzip. Okay, cool. So how about reversing the gzip? How can we get the tarball back? Well, this is very easy. All we need to do is just, if I clear the screen, unzip our archive.tar.gz. Okay, so you just use unzip on whatever it was, and when you do that, you see it's now back to a tar file. And if we look, we can see that it's a tar file. We're using the file command, so our archive.tar, and it tells you it's a POSIX tar archive. Hooray! Okay, so we've managed to undo the gzip operation. Okay, so what about bzip2? Well, bzip2 is a more heavy-duty compression algorithm, and now it takes more computational time than gzip, but usually, not always, but usually, returns more compressed files than you get with gzip. Okay, so it's a bit of a trade-off. Now let's compress our tarball with bzip2 and see what we get. Okay, so it's very easy. All we have to do is bzip2, our archive.tar. And when we see that, we now see that it's gone and got the bz2 file extension. And if we use the file command on it, we can see that it says it's bzip2 compressed data. It doesn't tell you what it was before it was compressed, so we lose a bit of that information, but it has indeed been compressed, and the file command knows that it has. So how big is it? Well, if we take a look with the L option, we can just have a look right there, and we can see that this is 23,137 bytes. So it's slightly larger than the gzip version of 23,023 bytes. Now bzip2 is usually best saved until you have really large files. Now for these relatively small text files, it didn't do us much good to use bzip2, but on a large file such as a video, you'll definitely see a large difference between the compression results achieved by bzip2 and gzip. Now to undo a bzip2 compression, it's actually very easy. All we've got to do is bunzip2 and then whatever the bzip2 archive is. So in our case, this archive.tar.bz2. And when we press enter, we see that we've come back to the tar file, and again we can use the file command to check, and we've got our tar archive back. Now there are other compression algorithms out there, such as the XZ compression algorithm, and if you want to see a more in-depth comparison between the performance of gzip, bzip2 and the XZ algorithm, I've put a link in the resources section for you to find out. Now there is something that you should bear in mind, however, which is how do you create zip files? Now zip files are files that you know, are commonly used on Windows or Mac, and you know, as compressed archives. Now they're not I don't think they are as compressed as what you'll get with gzip or bzip2, but they are commonly used on other operating systems. So if you want to create a zip file, it's actually a one-step process. You'll just type zip, okay, then you'll put the file, so let's call it ourthing.zip, and then we'll put file1.txt, file2.txt, and file3.txt, and when we press enter, we'll see that we now have a zip file in there. So if I press file, .zip, it tells us that it's a zip archive data, and this is what you can use on other operating systems such as Windows, and you usually can't with gzipped files or bzip2 compressed files. They don't tend to work too well on other operating systems by default. You tend to have to install other software like 7-zip or WinRAR or whatever it might be to extract them, and of course you can just unzip that zip file, and it'll ask you, do you want to extract them all, and then you can extract them all. This is just asking us because it was like, oh, you might have to overwrite some stuff, but that's no problem. We just said yes, and that worked. So if you want to make zip files, zip and unzip is the way to go. So if we clear the screen, now so far we've been looking at compression as a two-step process. Okay, first we've been creating a tarball using the tar command, and then compressing that tarball using either gzip or bzip2 or, you know, any other compression algorithm. Okay, but is there any way to do it in one step? Well, because creating backups is such a common thing to do, the answer is yes. You can actually create a tarball and compress it using a compression algorithm straight from within the tar command. So let's just delete our tarball for now in our zip folder. So our archive.tar, we're going to remove that, and our thing.zip. So we're going to get rid of every archive that we've got, and then we're going to take it right from just the raw data here, these raw files, straight to a compressed archive in one go. Okay, so to create the tarball itself, how would we do that? Well, what we do is we'd do tar cvf, so create verbose and allow it to accept files. We're going to create our archive.tar, there we go, and file 1 to 3. So this is the way that we normally do it, okay? But now to compress the files, we just need to give it one more option, okay? So to do it with gzip, you just give it the Z option, okay? And if we do that, that will compress using gzip. And we should remember that instead of naming it as our archive.tar, because this is going to be a gzip file, we should add .gz at the end as well, just for convention, because it won't be added automatically when using this method, okay? When you ran gzip on it before, it was added automatically, the .gz file extension, but now because we're doing it all in one step, we have to provide the file name, so we need to add it on there, just so you know, it's a bit easier to see what's going on. And when we press enter, we'll see that our archive.gz has been created, and we can check that it is in fact a gzip file using the file command, and it says that it is gzip compressed data. So that's super cool, okay? Now, how would you do it using bzip2? Well, if we clear the screen, bzip2 is exactly the same, except instead of Z, you just have J. Okay, so if you have J, and now remember we're going to change our extension to bzip2, and when we press enter, we'll see that our archive.bzip2 has been created, and we can check that that is indeed valid by using the file command, telling it to look at the bzip2 archive, and it tells us that it's bzip2 compressed data. So that's how you can compress in one go. How would we go about extracting from those compressed archives in one go? Well, that's really easy as well. Okay, let's delete them again. Actually, no, let's not delete them because we'll need them, right? So here's how would we normally extract from a tar file. Well, how we'd normally do it, if you remember, is tar, then xvf, so X for extract, V for verbose, and F to accept a file, and you'd give it the tar file, okay? But let's try and extract the gzip option first. Let's delete these original files, and let's try and extract the gzip option first. So to extract the gzip option, all you've got to do is type the Z again, because Z is for gzip, okay? So you had the Z when compressing, you'll have the Z when extracting. All you've got to do is change the C to an X, and you're good to go. So when we press that, we'll see that now we've extracted them all out again, and we've got the data back. So if we delete these files here, if we just delete them there, now how about extracting using bzip? Well, you remember that J is for bzip, so instead of having Z, let's just put the J, and then we just need to tell it what the archive is, and remember that it's a bzip2 archive, so we need to actually change the name. So here we are, tar extracting verbose through bzip2 and then giving it the file. And there we are, we've extracted using bzip2. So it's very, very easy. As long as you can remember that Z is for gzip, J is for bzip2, you're sorted, and you can extract and compress all in one go. Hooray! So we've seen so much in the last 2 videos. It's quite hilarious that a section on compression would take so long, right? Anyway, let's have a quick recap. So you first learned about the concept of a tarball. Now, tar files or tarballs are just containers for you to store the files that you want to compress, okay? Now, you can create tarballs using the tar command, and tarballs do not really do any compression on their own. That's the job of a compression algorithm. The tarball just contains the files. And you saw how to add files into tarballs and how to extract files from tarballs using the tar command. And remember that there's a cheat sheet in the resources section for this video that will list out the different options and different ways of using the tar command. Now, once you have the tarball, in order to compress it, you need to use a compression algorithm. Okay, so tarballs can be compressed using a variety of different compression algorithms, and we took a look at gzip and bzip2, which are common options on Linux, but the xz option is another option. We didn't discuss it here, but if you want to read more about the comparison between the different algorithms, I've also put a link to a interesting blog post in the resources section for this video for you to have a look at as well. Okay, but with regards to gzip and bzip2, gzip tends to be faster but give less compression, whereas bzip2 tends to give more compression but take a bit more computation time. Okay, so that's just something to bear in mind, but by all means, check out the link in the resources section for a more in-depth discussion. You saw also how you can create zip files for compatibility with things like Windows or Mac using the zip and unzip commands. So that's something as well that you've got on record as well. Okay, and you saw as well how to not just do making the tarball and then compressing in 2 steps. You saw how to do archiving and compression in just 1 step using a variety of shortcuts, and all that stuff is in the cheat sheet that you can find in the resources section for this video if you ever need a refresher. Okay, it's all very simple, and once you look at the cheat sheet, probably you'll be able to see the pattern, but it's really quite simple stuff once you've done it once or twice. Okay, so all in all, you can now create your own archives and backups using the Linux command line, which is super awesome, because on this section all about learning how to use files. Now, when you've created your files, you've edited them, they've copied and pasted them, you've moved them, you've done whatever you want with them, you can also create your own backups and save for later in a space efficient way. So well done you. Now, in the next video, what we're going to be doing is we're going to be closing our discussion for this section on files and the file system. And I want to say that you've really come so very far in this section. In the next video, I want to take the time to have a recap of what we've learned in this section, and also to celebrate your progress. So well done you. Now, for a summary of this section of the course, as well as a deserved set of praises, I'll see you in the next video.